this course, I'm going to learn about the vibration. Lecture on this subject, 以前我们对，同学大家好，我们今天要上的是振动学。然后呢，这门课助教是属于，然后每周2、3上课。对，我们用的参考课本是通生这本比较经典的书。So the textbook we are using for this mechanical vibration is authored by Thomson. Okay, so also I refer a lot of your these books by Stater to help you gain the physical understanding on vibration. Okay, so the lecture slide and the tutorial or homework questions has been posted on E3, so you are asked to refer to the course website. Okay, so let's start on the introduction. Okay, let's see. Okay, so let's move. Okay, for this course, what we're going to try out, as for introduction, we are going to study what is good vibration and what is bad vibration. Good vibration could be the sound created by musical instrument. Sound itself is a vibration, but here we are looking at the structural vibration of the musical box. 所以同学如果看到音乐，OK， 它本身就是一个振动的力量。OK， so what is vibrating are the cantilevers of different length. So the longer cantilever, the lower the frequency. So basically, for an octave, you have 8 notes. 这个玩音乐的这个，你知道这个8度 ，OK， 频率是倍增 ，OK。So here what you see is a drum with a percussion. This percussion will then plug the cantilever up and down. This small vibration cannot be heard without an amplifying box. Okay, so just like you are shaking a ruler, you cannot hear the ruler vibrations, but with the help of the amplifying chamber, you can hear it. Of course, another reason why you cannot listen the ruler vibrating could have to do with the sensitivity. OK， 同学看到没有？这个音乐和它有像梳子一样的你可以说齿，也可以说是悬臂梁，非常短，也非常细。给它弹起来的时候，它会震动空气，然后这个空气进而经过你的这个音乐箱去放大，所以你会听得到。你们有没有？如果悬臂梁可以震出声音，那请问你们的铁齿，为什么晃动的时候没有这么大的声响？来，有把尺，再晃，OK， 可能要敲一下，敲一下 ，OK， 所以实际上是有声音的，不过就是你的力度，所以你晃的时候本身叫做刚体运动。So when you have a ruler and you wave it, so you are not creating any sound because this whole ruler is doing a rigid body motion. A rigid body motion means that, okay, zero is elongation, and this motion is very slow in frequency. However, if you now configure them as a cantilever and plug it in, then it will vibrate very fast. Only when it's vibrating very fast, then it will excite the air and creating a pressure wave that transmit up from one side to another. 就好像你在池里面这个丢石头， 可以产生波动。但是你如果说你不是丢石头 ，OK， 你是池里面这个载了一个船，那个船上下动，它产生的波跟石头产生的波哪一个大？当然船的波那个是能量非常高，但是波动频率就很低，所以你就可能看不到这个大船产生的波动。但是池里面丢了一个小石头，它这个波的传动就比较明显，然后你就有可能到，所以就听不到。同样的也是一把尺 ，OK， 你在那边晃，那个是超低频的，就是所谓超低频是1赫兹以下的振动，然后磁本身固定成旋臂量，它的共振点就比较高。Okay, so that's an example. And of course, so you have also unwanted vibration. This is a musical instrument. Unwanted vibration happen during the earthquake, and unwanted vibration happen during concrete breaking. You are using the concrete breaker, and then that kind of back vibration could be a danger, causing a fatigue to the worker. Okay, what's the objective of this course? So we are going to learn the basic concept about vibrations. So what are the vibrations? There are free vibrations. Free vibration means that after it was put into vibration, there are no more force that move it to and fro. 所以我们之后要学的振动有自由振动，有自振动就有点像单板，它就你给它激活一下，它肢体就咬了，你不用外在的往复的力去击振它。另外一个要学的 the second one we're going to learn is about the force vibration. In this case, the force vibration are subjected to a harmonic force, a time-varying force that move the body to and fro. Okay, and special kind of force vibration happen at a natural frequency. Then resonance happen. Then you are going to subject to very high amplitude of vibrations. And next, we're going to study the vibration in terms of natural frequency, mode shift, and we're going to write the equation mainly in Newton's second law to formulate it and then predict the natural frequency and the mode shift. 所以我们接下来要学的这个还有一个就是自然频率跟模态。可能我们就拿一个例子给大家看一下。我们的自然频率，自然频率是它自由放动时候的频率，但如果自然频率跟外在的这个频率吻合的时候，你可能就出现共振的现象。好，我们先看一下一个短片。OK， 好 ，So what is the free vibration? So I can show you some short video. Okay, this is the free vibration. Okay. And then what is the force vibration? So we are looking at the force vibration. So you have this force vibration. Okay. So it's a simple pendulum. So here is free vibration. Force vibration is the one that applies the force either periodically or aperiodically. 这机制本身就是要有一个外在的激励 ，OK， 所以频率可以改变，或者是这个机制频率可以改变 ，OK， 这个概念 ，OK， 这是这个过程的一下。好，然后我们再看一下共振 ，OK，So what is resonance? So we're showing you some of the example about the resonance, OK. So this is a wooden suspended bridge， 所以是木的这个吊桥。OK， 如果你有2组人一上一前一后的跳，所以你可以带动这个桥面做上下运动。OK， 所以你单纯是用走过的，这个桥不会跳。OK， 但是你在这个重要的位置上，然后有节奏的起跳，你可能就会 把这个桥的这个共振频率给振起来。So in this case, so you have two group of people standing at a different position. So they are jumping up and down to excite the outplane vibration of the bridge. So this frequency of the force application got to be timed properly in such a way that then you can increase the amplitude of vibration of the bridge. Okay? So besides human excited vibration of the bridge, so we're going to see the vibration of the what we call the bridge. Okay? Yeah. So let's see here. Yeah. So that's the one. So this is the video from YouTube created by NASA. It's about the fluttering. This is wind-induced vibration. Okay. So there is a bridge called Tacoma under the blow by the wind at the right speed. We create the vortex. The vortex induces change of the pressure. So this is not the bridge broken down by the typhoon, okay? But it's caused by the wind that creates the vortex. Okay? So don't think of the flapping wing will be safe if the fixed wing start flapping, then it will be catastrophic. 所以这个是翅膀的结构。那固定翼本身如果说发生共振，那是非常危险的事，因为这表示说你的这个流动的气流的结构，然后这个频率如果刚好跟结构相吻合的话，你就会造成很大的这个涡流。你看到没有？这个涡流是一下子在上面产生，一下子在下面产生，所以你的这个太空梭也好，飞机也好 ，OK， 所以只要是结构或者是旋律啊，它开始就会产生激震，然后激震的频率刚好是跟它的结构频率一样的时候，就发生共振。OK， 共振的时候，你的结构就可能因为振幅过大，然后就折断。OK。During this video, do you think the aircraft is too dangerous to be on board? 来，如果看完这影片，是不是所有飞机都这么危险？在这样的情况底下，会有涡流产生的共振。Okay, how do you think? Okay, is all aircraft that dangerous?
Sorry?
Does all aircraft will flutter? In what condition the flutter will happen? What do you think?
Let's say it's just at the natural frequency of the.
Yeah. So that happens only when aircraft is flying at very high speed. Okay? So for all the aircraft, before you're going to take off, so somebody got to drive the aircraft to the extreme speed. Okay? 所以你要驾飞机驾到极限速度，然后气流的流动速度非常高。所以它的这个产生涡旋的频率高到跟你的结构频率相同的时候，那个就会发生共振。Okay, then next time I will be asking, how do you fly the aeroplane to the extreme speed? 怎么把飞机降到极限速度？来，我们问一下同学。同学。想把飞机降到极限速度 ，how do you fly the aircraft to the extreme speed?
增加推力，
嗯，
增加它以前的推力，然后
你确定吗？增加推力是唯一的方法吗？OK，OK，好，那我就明白明白。破坏涡流。OK， 对，我们是操作飞机，然后让它飞到极限速度。怎么操控？ 手迎风面的面霜，对不对？所以我们就看一个结论的影片，然后说，那天我已经只有调成了这个。Okay, let's watch this. Okay. 你最近要
雅诗兰黛手棕皮七号宣布疫苗启动，保湿弹嫩，雕塑明星。
全新 Galaxy S23旗舰系列预购送原厂3大好礼。
Okay, the aircraft can fly to the listening speed when it's diving. So it's just the same way like the birds flying. Okay? So the penguin subjected to resonation.
When it comes to raw speed, no creature on earth can match it.
所以像这种
Commercial pilot Ken Franklin raises its
这种鸟，
sounds to see
它在极限速度的时候会共振吗？表示吗
What characterizes a peregrine falcon is
？OK， 你看它就看到了。
its ability to hunt at high speed in the open airspace. The more that I was involved in flight with birds and started seeing their speed,
所以你
the more I
在
wanted
就
to
是垂直落体的时候，
be
飞机是可以到极限速度，
尿不行。
要么就是闪现，要么就是在震。OK，OK。
To answer that question,
然后鸟的话呢，
specialist.
鸟它也是垂直落体表现。OK，
He'll test your
像它会共振嘛。So with the bird's wing resonate when it's diving down.
A tiny computer like those used by skydivers is clipped onto feather shafts just under Frankel's tail covers.
OK，
Ken is confident it won't affect her performance. The Cessna strained to the thin air at 15,000 feet. Although Wild
so
Falcon
they bring this version up
this
to
is the
high up.
highest flight goal it's ever been,
And
right?
later launch it, release it, so
At
that
12,000
now it's diving.
feet, she goes into her dive.
Okay, this is a free falling of the a skydiver.
After 10 seconds, she's going 120 miles an hour.
120
Ken releases the lure.
miles.
21 seconds. Frankel shifts into hyperdrive. That's what Ken's been looking for.
Okay,
She shifts her shape to slip through the air's molecules. 43 seconds. She catches the lure, pulls out of the dive at 3,000 feet, and heads home.
okay, so this is. So why the
Moments
user
later,
don't
Ken
resonate?
shoots, snaps open.
Okay, first they close their wing. Okay, they tuck in their wing. So
The verdict is in.
unless you expand your wing, then you are subjected to high force.
And Ken still doesn't know how
And
much
second,
faster she
most
can go.
importantly, your head or the bird wings are multi-segment. Okay? So it is free to move.
It's like karate
Okay?
in the air.
The resonant frequency is what?
Hyper streamline.
那你们的手的自然频率是多少？啊？来，我们说看手的自然频率是多少？So what is the natural frequency of your hand?
How do we measure?
啊？
怎么量？
高还是低？
算低了。
低，多低？So what is the natural frequency of your heart?
Maybe 10 hertz.
对，接近于小于1赫兹。Okay. Why is it so soft? Yeah, because your joint. Okay. If you muscle don't contract, there's no stiffness, almost no stiffness in the joint. Okay. Any machine, any structure that resonates must have elasticity. Okay. If it doesn't spring back, so there will be no resonant frequency because the natural frequency is 0. Okay? Without spring, there won't be any vibration. Vibration means a motion that goes forward and backward. Okay? So that's the main thing about vibration. And how about pendulum? Why pendulum can swing to and fro? Okay? So if you now, okay, we don't have the roof, okay? Also don't have the, okay, take for example, if I take this cable, okay, as a pendulum, okay, so this cable will move to and fro. There could be two reasons. One is the cable stiffness. Even if the cable has no stiffness, okay, but it will move to and fro because of the restoration force by gravity. 所以单排的话，它的运动，它虽然没有弹簧，但是你的重力，一直的朝向都是往中间最低的地方拉，所以这个重力本身，它就形成一个等效弹簧，不断的把单排拉到最低位置。OK， 所以弹簧的定义是，它可以把你拉回能量最低的，就是弹性势能最低的位置。而重力呢，如果跟单板作用，它只限单板，重力作用在悬臂栏上的时候，它就不是弹簧。OK， 重力作用在单板上，它是有一个往回拉的这个趋势，但重力作用在单板上，它是有一个方向拉。OK。So in this case, the presence of the restoration force is important for the achievement of this spring force. Okay, next. Let me see here. Okay, then next we're going to learn about okay. So please forget about the week number. So if you are looking at this, let me see this slide. Okay. So that's the one. Okay. The one, say. So the first thing we're going to learn about is about the free vibration. So first example going to be pendulum. So we're going to study how the pendulum oscillates. I think you learned it in your, in high school or secondary school. But this is part of the physics. We're going to start with that. So to help you get a better understanding about free vibrations. So we're going to first measure the oscillation, and then later formulate the equation using Newton's second law. And the most importantly, we're going to solve this equation of motion by using some simple ordinary differential equation. 我们将用简单微分方程去解这个单摆的这个运动方程。Now here, later we're going to introduce you about the mass, moment, and inertia. In the next example, we're going to study is about the mass spring system. 好，我们先看一下这个简单例子。Okay. So what is the common thing between the simple pendulum and the mass spring system? You can observe that the motion of the pendulum is a left and right swing. So you're going left, right, left, right. So if you track the angle over the time, you see this oscillation. Then the next thing about the mass spring system is you have a mass in the spring. When you release the mass, then they will start stretching the spring. And when the spring is stretched, also called the overstretch, then you recoil back. So then you have the mass moving up and down, up and down. So in that way, if you following the mass center, over time, you see this sinusoidal wave. This sinusoidal wave has a feature of repeatability of common period. Okay. So how the mechanical pendulum works. So the invention of pendulum happened in Europe, in Italy, okay, in the Middle Age. Then Galileo invented this pendulum while he's observing the candlestick's vibrations in the church. Okay, let's see the reinvention of the Galileo pendulum. 我们看到这个伽利略单摆，那基本上是有一个单摆，再弄一个 escapement 的机构。这个 escapement 机构基本上是如果没有被抬起来，它会被上面的卡住。OK， 这个是会卡住，这个有点像转轮的这个叫 escapement 机构。然后这个卡被抬起来过后，这个轮子在重力作用下就会转动。OK， 所以 there are two mechanisms here. One is pendulum, the other is escapement. And then the escapement will then bring the shaft and start the rotation. So this escapement will be stopped by the pendulum. Will be released by the pendulum hook. Okay, you see, it's released. Then this wheel will start rotating. And then in turn, the wheel is going to set a series of gears. And that series of gears will then turn the dial of the clock. 所以单摆有一个很重要的这个性质，就是它每个周期的来回摆动周期都是一样的，不管你是开始或结束。OK， 不过单摆因为它还是用材料组成，所以单摆的频率会因为材料的变化而改变。所以我们要找一下一个公式来叙述单摆的周期值。Okay, so we're going to study how are we going to figure out the period of vibration, free vibration of a simple pendulum. One thing a pendulum is a rod and a mass. Because the mass of the tip of the rod is so big, so you can assume that the rod carries no mass. So in a simple pendulum, we have a massless rod. At the tip of the rod, then you're going to have a point mass. Okay? So these rod has a length L. Okay? So we're going to see the motion. When you start the pendulum, okay, how do you look at the pendulum? Okay, that has a room, has a pendulum. So you can use the单摆，这边的扫把。So this is a pendulum. Okay? So if I start the oscillation, okay, so you can see that the starting of the oscillation must start with the mass elevated up, okay, and then my finger will hold it like holding it a pin. 所以我在抓这个扫把的杆的时候，我是当成一个 pin joint 去支持它，没有抓紧，然后释放的时候。它就在我的手上转动 ，OK， 所以这个来回的转动 ，OK， 它的这个周期是跟杆长相关。不相信的话，我支点放在这里，同样的一个单摆 ，OK， 那这个杆的频率就摇动频率就提高，到时候再短一点 ，OK， 那频率会更高。当然，这个扫帚还是比较复杂的单摆，因为这个杆本身很重量，扫把的头可能重量多一点，但杆本身很重量。So this is the modeling of the vibration pendulum. So here you can see when you start releasing the pendulum. So you start with the starting angle, theta max. When it's released, because the gravity will pull the force toward the lowest point. So that mass will gain in the speed moving to the lowest point. But once it reaches the lowest point, because of the speed is non-zero, you keep the mass going to the opposite side. Okay? And when you reach the opposite side, most of the kinetic energy has been converted into gravitational energy, gravitational potential energy. Then you come to the stop. Okay, 当单摆从最上的位置释放，然后它重力的拉动下，它会增加速度，到最低点的时候速度归零，然后这个速度会继续让这个单板往前冲，然后这个冲到一个位置，提高势能，然后这个速度变零了，它就冲上去，然后势能为零的情况底下，这个动力又反向把它拉回最低的位置，那到了最低位置，它速度就提高了，然后又滑到对面的位置。So you can see this pendulum motion. If you track by angle, the angle will start at position 1 being non-zero. At position 2, it becomes 0. At the opposite point, the angle becomes negative. And once you come to the swinging back, okay, you come to the lowest point, position 4, and finally you reach the initial position. So if you observe this oscillation, you can see that the peak remains the same if there is no damping. And then the time taken for one peak to go to another next peak is what you call period. Okay? The maximum amplitude from the peak to the neutral point is what you call amplitude. 所以你如果单纯只是跟踪单摆摆动的角度，你会看到这个周期性的运动有点像正弦波。这正弦波的峰值 ，OK， 是维持一个值。如果说你没有这个注意 ，OK， 然后这个峰值到峰值所花的下一个峰值所花的时间，就叫做周期。周期的导数，就是你所谓的频率。同样的，你除了跟踪角度，你也可以注意你的这个速度，在你释放的那一刻，速度为零，角速度为零。到最低点的时候，角速度最高，然后到对面最高点的时候，角速度会变为零，然后它反向这个在最低点的位置，角速度变得更高，然后到原始位置的时候，另外一个高点角速度为零，所以把角速度拿去再一车微分，你会得到角加速度。So what you see here is the angle over time. If you do differentiation of this, then you're going to obtain the angular velocity. So the sine wave will become cosine wave. And if you differentiate the angular velocity one more time, then you're going to have negative sign. So in that way, your acceleration is a reflection of your angular displacement over time. Okay? So as for start, you can see that this periodic motion, okay, can then be expressed as a sine wave. Okay? It has an amplitude called theta max. That's from the point to the peak. And you have the inner part of the sine. Sine will become a complete a period when angle change by how much? 请问角度要变化多少？这个正弦函数才会多少？
周时90 degrees。
你的这个正弦要恢复到原值，角度要变化多少？一个周期，对正弦而言，角度要变多少？还是一个周期
360。
？Yeah, 360. So to complete a cycle for sine wave, you need 360. 360 is 2 pi. Okay? So how many cycles you have? It is the frequency times the time. What is frequency? Frequency is inverse of the period. The time taken it is 2 seconds, but if the period is 1, it means that you have gone through 2 cycles. So for a sine wave to go 1 cycle is 2 pi. Okay, how many number of the cycle is your time span divided by period. And period inverse is your frequency. So you have 2 pi x. times time second. So this 2 pi n will give it another name. We are familiar with the frequency, which is in terms of 1 over second. 2 pi n will then become what we call the angular nature frequency. So 从这个公式大概知道，你要叙述一个周期性运动，所用正弦波，你要知道它的骨质，你要知道周期，但正弦的这个函数呢，它的输入函数是角度 ，OK，360度一个周期，你这个时间段里面它走了多少周期，就是你的这个时间段除以它的周期时间 ，OK。So then next, here we're going to define you what's amplitude. Amplitude is the maximum amplitude of the oscillation of the equilibrium form. Remember, it's of the equilibrium form. It's not a absolute variable. And then the period is the time taken to complete one cycle of the oscillation, like sine function. So you take 2 time to complete one cycle, and then the natural frequency is defined as one over the period. And for the ease of understanding, we also define what we call angular frequency. Omega is 2 pi n. This is 2 pi over the period. This is what we call angular frequency. Okay, and then the last part, okay, we'll come to the base later. But let's have a look at the experiment. 我们来做一下看一下简单的这个实验。With the actual experimentation. Okay, let's go on. Right, and bring down the old data. 好，我们是先把理论上，等一下来做那个看你先做实验。Okay, so next we're looking at the equation. Other than the omega t, so we have now the phi. What's the meaning of the phi? Phi means that how do you start the pendulum? Okay, there are a few ways of starting a pendulum. Okay. If you start here with 0 angular velocity at time 0. Okay, so this goes 2 and 4. Okay, so your angle versus time is theta max and sine omega t plus what? Plus phase. So what this phase? Okay, looking at here, at time 1, the velocity is non-zero, is 0. Okay? How could you have velocity become 0? Okay? So let's check. Your angular velocity is theta max times omega cosine omega t plus the phase. Okay? If you want the velocity, angular velocity to be 0 at time t, theta max is non-zero, omega non-zero, cosine, okay, the input angle is 0 plus 1. Okay? So here what can you find? Cosine phi is equal to 0 divided by theta max omega. So what is theta here? 所以我们在这个输入这个正弦函数，你是输入角度对， 这个所花的时间，你可以用所花的那个经过的角度，你可以用角自然频率乘上时间。OK， 但是还要加上一个相位。OK， so here you have another thing called phase. The phase is to adjust the starting point of your sine wave. So in this case, when you're releasing the pendulum from non-zero position but zero angular speed, okay, the sine wave cannot describe this motion, okay, because the initial conditions are different. If you are using the sine wave itself, at time zero, sine is 0, okay. So meaning that you are not going to have non-zero angle at the beginning, and some more, you're going to have non-zero speed at the beginning if you differentiate sine wave. 所以我们刚才随便讲的就是说，我这个叙述这个来回的整空是用正弦函数，那是不对的。因为你初始状况不一样的时候，你可能要用移弦，而不是正弦，也可能不是移弦，也可能不是正弦，是移弦加上正弦。OK， 所以你要是怎么选择呢？我们就用相位。OK，another way of understanding the complete solution is this angle can be written as a cosine omega t plus b sine omega t. Okay. So in this case, when we do the differentiation and comparison of the amplitude, we eventually find cosine angle is 0. And what is phase angle? So what is phase angle? Cosine 角度是0，是90度。Okay. That's right. So your answer for this is your theta max times sine omega t by pi over 2. Okay. And in this case, okay, how is it related to theta max sine omega t plus 90 degrees? Are these identity? 所以我们如果要带这个公式就相对简单，这个 A 跟 B 是代测的，所以刚开始的时候，在时间为0的时候，这个 θ 等于 θ max，A 就等于 A cosine 0加上 B sin 0。OK， 所以这个消掉，这个是1，是你的 A 等于 θ max。OK， 然后这个角速度呢，另外的 angular velocity for this case is that equal to minus omega A, and then sine omega t plus b omega sine omega t. So you're going to have a 0 angular speed at the beginning, and then this what you see b. So this is minus omega A times 0 plus b omega. Sorry, this has to be cosine. Okay. Then cosine 0. Okay. So in this case, what happens? B is non-zero. The cosine is non-zero, but the left-hand side is 0. So B is 0. Okay. So here the important point is, we got to start learning about the identity, and that help us. Okay, what's the identity? So 我们学正宗要学这个它的函数，所以这个θ等于 A 把你的边界条件带进去。OK， 所以你得到的是什么 ？A 是 beta net，B 是。So upon substituting your answer, then you're going to upon substituting the initial condition, you obtain the coefficient, and that will end up to theta is equal to theta max cosine omega t. So this is exactly what you obtain from the expression. Okay? Because of the identity of the two expressions, okay? So sometimes you want to convert the form from one to another. How do you convert the form? 所以我们学自然函数后面这个自然整通都是学正弦离弦，但是我们正弦离弦学的是三角恒等式。So what you learn is about the identity. Okay? So if you're not sure what that's it, then just take it. Okay, what this expression? This expression, you can write them into what? What would you like these to be? OK， 所以同样是这个式子，但是我可以把它写成什么？你要把它写成 sin、cosine、cosine、sin。所以如果这是 sin 的话 ，OK， 这就是你的这个角度 ，OK。所以如果是这么写的话， so because of this, then you can be writing it using the trigonometry identity, and this will give you your sin phi cosine omega t plus cosine phi sin omega t. So in the end, you can write this as sin omega t plus phi, and with the additive square root of a squared plus b squared. Okay, and then this is your theta max. Okay. Okay, 所以以往我一般都没特地去讲这个三角恒等式，三角恒等式通常是到这个第二堂课、第三堂课，但是这一层中就一开始讲的话，你们这个比较清楚。Okay, so let me copy that. case. Okay. So you have your example here. Okay. Okay. So how to find the base? To find the base, you do the time differentiation once. So this is marked by a dot. Then it's basically the time differentiation with theta and e. So this one, after differentiation of sine wave, then you're going to obtain cosine. Okay. And then next, you substitute the initial velocity. Okay. To find the phase. Okay, phase is the starting phase. Then this is basically at time 0, 0, when this is 0. So then you obtain your cosine phase is 0. And then you find out your answer. The phase is 90 degrees. So this 90 degree is then pi over 2. Okay. Take a while now. Then we then obtain the phase. So alternatively, okay, we also learned about this triangular identity. The same question, okay, can be solved using other functions. Okay, we will try to solve it. Okay, rather than using this function, you will say from this equation, apply the initial angle, then you obtain D to be equal to the theta max. Times 0. Okay. Then you find your theta max is equal to 0. Okay. And if you apply the initial velocity, okay, then you equal it to be 0. And this one becomes, after differentiation, you have this omega, and this one becomes negative a omega sin omega t, and this one becomes b omega cosine omega 0. So in the end, you have 0 is equal to b. Okay? And the complete solution. Okay. Is when your theta max okay. So this is by another form of expression. So this is in the final class. Then I'll use it to really please solve for the trigonometry identity. Okay. So you're going to prove. Okay, can you prove this? Prove that both are identical. Okay, the other one is okay. It's an exercise. Okay. So the hint for that is yeah. Phi phi. Let's see where it is at. Okay, this is the hint. And also break, I will bring the video from my hard disk and then coming down again to show it. 这个我们休息在这，再下来。 can one of you do the timing？来为目标计时，OK 吗？然后到影片这个上半结束。好，我们先从这个开始计时，看它的周期，1、2、3。我们看这个4段1，其他同学算。好几下。Did you count the observation? OK，来停。
3、8、
所以时间多少？
我中间按停了。
哦 ，OK， 那我们再来一次，一边计时的，然后其他同学算他的摆动速度，摆动这个次数。那我们再来一次，1、2、3，看影片，知道吗？念出来，一下。哎，多少次？13次。时间多少？
超级不准。
啊？你不会超就不出来。同学算都是每次13次，这样你那个起始时间跟结束时间。
听课的时间很难说。
哎，再来一次。哎，你们这个算那个摆动次数的，来念出来，然后你这个时间什么时候开始？就是释放的时间开始。
哦。
然后1、2、3来，我开始播。你就喊开始。1、2、3、4、5、6、7、8、9、10、11、12、13、14。OK， 停，这里是4，所以你的时间多少？
差不多20秒。
啊？
差不多20秒。
20秒。Okay, so the period of the oscillation. Okay, how to calculate? It takes
可以直接这么
the
用时间
total
走
time
多久？
懂。
of 20
小米
seconds,
我不懂。
and then the number of cycles
13
is
3口就
40
13是半吧
13半
？13半。
13半啊
13半。
13点，还没走，还没。
所以你的周期多少？你的频率是多少？来，多少？多少？
0.67。
那个是
676。
对吧？OK，所以你的周期是0.67，你的频率是0.67赫兹。OK， 好，然后我们来看下一个实验。实验前节目一下，同样粒苹果，同样一根杆，频率是快还是慢？做实验。
特质。
So with the natural frequency differential or the lesser? Yeah,
The same because it doesn't show up in the equation.
you think it's the same? Okay, we will come out the Newton equation here. But let's play the video. Okay, then do the experiment. 所以一样，计时你就喊什么时候开始，然后其他同学喊这个周期数，1次、2次、3次。
开始。
18、17，OK， 现在17.5，OK。 这个总时间多少
21，
21 OK 好 so the total time taken for this 17.5 cycle OK 来同学算一下这个周期是多少这个平均是多少几点我就有几
83，
0.83 0.83可以看到没有？同样的杆，同样的苹果，支点不一样，这个频率提高了，这到底发生什么事 ？OK， 所以我们是开始就要做解析的分析。OK，so now we're going to analyze. So how do you predict the natural frequency of the pendulum? This is so easy, okay? But I guess in your high school you only learn about a long pendulum and an apple. You don't have it or you don't support it in here. But in this case, there are variations of the pendulum. How are we going to solve it? We have to learn the method. The first thing we do is we're going to write the Newton's law for the apple. Okay? So our pendulum is made of apple and a string. So this is not the apple from Newton, this is the apple from Galileo. Okay? But you are applying Newton's law to write the equation. When this apple is released, then it's going to have tangential acceleration. This tangential acceleration is then equal to the pendulum arm and the angular change. So L theta double dot. Okay? So and what is the force causing this? It is the pulling force that contributed to the tangential direction. Where is this pulling force? This pulling force is coming from the gravity. Okay? So before you solve this problem, please draw the free body force diagram. What is your free body force diagram? Before you define free body, your free body is a mass. Okay? Where is this mass position? This mass position depends on the rod. It identifies clockwise angle to be positive. Okay? And then you have the clockwise positive velocity. You have clockwise positive acceleration, all angular acceleration. Okay? So all in the same direction. That's the definition. And then next, your previous Newton law, mass and tangential acceleration, cannot be written as mass times L theta. Okay? If you are not sure about how the tangential velocity, tangential displacement related to the angle. This is the arc length. So it's basically the arc or radius times the angle. So of course, your tangential velocity is L theta dot, and your tangential acceleration is L theta dot. Because your pendulum arm don't change. What change is then your angle? Okay. And next, what are the forces? So at this position, okay, you have the gravity. Okay. And because the gravity will then have two components. One is the radial component, which was counted by the rod. And the other component, which was not counted, okay, is then countering the direction of your tangential acceleration. So this is minus mg sine theta. Okay. There's a 最难是什么？画图。你如果第一张图画错，你是不会答案的。哎，最难是单法。你如果一开始画的图就是，哎，这把扫把会画吗？哎，再去录一次，扫把会画。So the most important thing about this writing of the equation for vibrating body is you need to know the positions of the body that will vibrate. Okay? This is the same pendulum of rule, but it is at the equilibrium positions. You have the weight countered by the rod tension, so they are not going to be at any rotation. Okay, only you leave it up so that the tension is still along the rod, but the weight remains vertical. Okay, and then that vertical force will then have a tangential part to pull the pendulum back. Okay, so if your first equation, your first drawing of the free body was wrong at the equilibrium position, you are not going to obtain your free vibration equation. Free vibration equation must be two of the equilibrium position. Okay, so that's the way. And then next, after you write the equations, okay, so we're going to do the simplification of this equation. So let's move the equation n m theta double dot plus n g sine theta equal to 0. Assuming the angle is small, sine theta is nearly equal to theta. So in this way, then you obtain a second order ordinary differential equation. So we divide both sides by ml. Then you have this being 1, this being g over l. And this is what you call your equation of motion. Okay? So what's the solution to this? Okay? Even though you didn't done any mathematics, but by looking at the physics, what would be the solution? 所以即便你没上公数，经过我们刚才的这个实验验证，所以你觉得要叙述这个角度是用什么函数？ Okay, yeah.
Yeah, a sine wave, because the equation needs to be
Yeah.
equal to
Yeah,
the second derivative of the of the sine wave
yeah,
needs to be
Yeah.
negative. So
yeah, exactly. So even my point here is, even I don't learn any mathematics, but the physics already tell you it's going to start with the starting angle, come back, and then coming back, and then yeah. So this is the sine wave. So your solution is going to be theta amplitude sine omega t plus phase. Okay? So now, if you differentiate one more time, then you've got angular velocity. And if you differentiate second time, then you have minus omega squared a sine omega t plus phase. Okay? Look at what are you going to substitute into the equation? Okay? This is the angular acceleration. And then this one is your angle. What is common between angle and angular acceleration is your a sine omega t. Okay? So next, based on this, then we can doing the simplification of the equation of motion. Okay? What I'm going to take out is a sine omega t plus the phase on the left hand side. Okay, this is a common factor. Besides this common factor, if you see this, the first term will then be minus omega squared, and then second term, there's a coefficient plus g over L. Okay? So this is my equation of motion re-expressed. Okay? So I'm talking about this equation of motion. Obviously the Newton law. Okay? Let's check. What is the solution? Is amplitude 0? Not 0. But the right hand side is 0. Is the sine 0? Occasionally. Okay? So it's most of the time not 0. Otherwise there will be no oscillation. And then what must be 0? Since your right hand side is 0, your left hand side has one term 0, and this is 0. So you have omega squared minus g over L. And then you have omega being square root of z over L. And what is omega? 2 pi L. So as a result, your frequency is 1 over 2 pi times square root of g over L. Okay? So you can see now here, what is the relationship between frequency? Okay? For a simple pendulum. Okay? Okay, let's go through with you the step-by-step guide on 344 diagram. So here you have the equilibrium position. Next, you perturb it with the angle. And from that angle, you have the angular velocity, angular acceleration. And then next, you're going to identify the force. The force acting on the pendulum include the tension and the weight. But only the tangential part is causing the motion and acceleration. That tangential part comes from the weight. They are pointing toward the linear line. And that tangential